Hi everybody, welcome to Mitch Maths. My name is Mitch and today we're going to be looking at multiples, factors and prime factors. And in this video we're going to be going over what each of these are and how we can work them out. So let's get straight to it then and look at some multiples. Okay, so what is a multiple then? So a multiple is essentially all the numbers that your chosen number will go into. And that is essentially its times table. So that's all it is. A multiple is just the times table of that number. So for example then, if we wanted to know what the multiples of 8 were, usually questions like this will ask you for, say, the first 8 multiples of 8. So what you do is you start off with 8, as that's your first multiple. 8 times 1 is 8. And then you go through the times table. So then your next multiple of 8, it would be 2 times 8. So that would be 16. 3 times 8 would be 24. Then 32, 40, 48, 56, and 64. So here we go. Here are our first 8 multiples of 8. And as you can see, it is just the times table. And it's as easy as that. Right, so moving on to some factors then. First of all, what is a factor? So a factor of a number is all of the numbers that will divide into it. So this one takes a little bit more thought than multiples. So whereas multiples are all the numbers that that number goes into, we know that all its multiples will be bigger than that number. Factors is just the opposite. Because it's all the numbers that will divide into it, we know that all the factors must be smaller than the number we're asked to find the factors for. So let's go through a quick example then. So a good example is, let's find all the factors of 36. So I've chosen this because it has quite a lot of factors, so it'd be quite a good example to go through. And the best way to find all the factors of these numbers is essentially to start from 1 and work your way up 1, 2, 3, 4, counting upwards and seeing if they're in the times table of this number. And then you'll write down all the times tables that make up 36, and then those will be your factors. So let me show you guys how you do that then. So 36, the first one would be 1. So we know that 1 will go into every number, or every whole integer. So we know that 1 times 36 is 36. So we know that those will be our first 2 factors. And if 36 was a prime number, they would be our only factors as well, just 1 and 36. But we know that 36 is not a prime number, so there are lots more to go through. So we've done 1, so next we'll do 2, and we know that 2 times 18 is 36. We'll move on to 3, and we know that 3 times 12 is 36. Moving on to 4, and we know that 4 times 9 is 36. All these equal 36. 5, so 36 is not in the 5 times table, so 5 is not a factor of 36, so we won't bother writing that one down. Moving on to 6, and we know that 6 times 6 is 36. If we go on to 7, 7 does not go into 36. If we try 8, 8 does not go into 36 either. 9, so we know that we already have 9 here because 4 times 9 is 36. So I could write 9 times 4, but because it's now repeating in one we've already got, now we know it's a good time to stop. Once we've gone up the numbers in order here, as soon as we hit one that we've already got elsewhere in our factors, we know that we can stop and we've got all the factors that make up this. So we've already got 9 times 4, so we don't need that one anymore because it's already accounted for. And that's it. All the numbers that we have here are the factors of 36. So let's just write all them out now then. So all our factors, so we'll write them in order. So you've got 1, 2, 3, 4, 6, then we've got 9, we've got 12, we've got 18, and we've got 36. And they are all of the factors of 36. If you're asked to find out all the factors of a number, just go through the numbers starting at 1, find out which ones are in the times table, and then write it all down, and that will get you all the factors. Okay, so finally in this video then, we're now going to be looking at prime factors. So what is a prime factor? So just like in the last part of the video then, where we looked at all the factors for a number, now we're just interested in the prime factors. So this is all the factors that are prime numbers. And remember, a prime number is one where its only factors are 1 and itself. So your first thought there might be to think, okay, so to find the prime factors of a number, all I have to do is follow the method that we did in the last part of the video, where we found all the factors of a number, and then just pick out the ones that are prime. And you're right, that would give you the prime factors of that number. However, a lot of questions that ask you for prime factors often say something like, express this number as a product of powers of its prime factors. And if you did that using the method from the last part of this video, you might end up missing a few. And to best show you how that would be the case, let's go through a quick example. Okay, so the example that I've got here then is express 420 as a product of powers of prime factors. So with all these sort of questions, the best way to find out the answer and the best way to find all of its prime factors is to make a factor tree. So I'll show you guys how to do that then. So we'll start off with 420 right at the top of our tree. And then what we do is we form branches off the bottom of this tree, just 2 at a time, and at the bottom of these branches we'll find 2 numbers that multiply to give 420. So looking at this number then, we can easily see that because it's got a 0 at the end, it is in the 10 times table. So the best way to do this, I find, is just to pick the easy ones. So we know that it's 10 times 42 is 420. So those are our first two, 10 and 42. We then look at these two numbers and we say, right, are any of these numbers prime numbers? And you can look at 10, you can look at 42, and you can quite confidently say, no, these are not prime numbers, mainly because they're both even. That's the quickest check. So we know that at least 2, and maybe other factors as well, will make up these numbers, so they're not prime. So because they're not prime, we'll keep going. So we'll start off with the 10 then, and we'll make 2 more branches, and we'll think, right, what 2 numbers multiply to give 10? Again, 10 is an even number, so we know that 2 must go into 10. And so we'll choose that one then. So we'll say 2, and we know that 2 times 5 make up 10. We'll then do the same thing as before. We'll look at these 2 numbers and we'll say, are these numbers prime? And we know that 2 and 5 are prime numbers, because we know that the only factors that these numbers have is 1 and themselves. So now we've found some prime factors, we'll stop on this bit of the branch, and we'll just give those a bit of a circle, just to let us know for later that those ones are prime factors. Moving over to the 42 then, we'll do the exact same thing on this side, do some more branches, and we'll look at 42 and we'll say, right, which numbers multiply to give 42? So we've got a couple of options here, and it really doesn't matter which way we'll go. We know that 6 times 7 is 42, and we know that because it's an even number, so 2 goes into it, and 2 times 21 goes into it as well. And it doesn't really matter which one we'll pick. I'll just pick the 2 times 21 just because it's even, and we'll just halve it. So we'll go 2 and 21. Are these numbers prime? 2, yes. So we'll circle that one and we'll stop on this side of the branch. 21, is this prime? No, it is not prime. So on this one we can keep going. So we'll form 2 more branches and we'll say, right, what numbers make up 21? And we know that 3 times 7 is 21. Again, are these numbers prime? 3, yes. We'll circle that one. 7, yes. 7 is also a prime number, so we'll circle that one. And now, as you can see, the bottoms of all the branches are now circled because they're now all prime factors of 420. So now the question asks, so express 420 as a product of powers of its prime factors. So now we need to do that then. So we can say 420 equals, and so a product is basically all the numbers multiplied, and it is also of the powers. So for example, in this one, we've got 2 2s here. So we'll say it's 2, And because it wants is the product of the powers, and we've got two 2's, we can say 2 squared, because 2 is the same as just 2 times 2. So we can say 420 is 2 squared, so we've done that 2 and that 2, multiplied by 3, the next one, done that one, times by 5, we've now done that one as well, and lastly but not least, times 7, and we've now done that one. And now we've covered all of the prime factors that we found in our factor tree. This is now our complete answer. This is 420 expressed as a product of powers of its prime factors, and it's 420 equals 2 squared times 3 times 5 times 7. And that is the answer to that question. If you ever get faced with questions like this, by far the easiest method is to draw out this factor tree. Just pick the really easy ones as you go down. If it's even, you can always halve it. If it ends in a 0, you can always divide it by 10. If it ends in a 5, you can just divide it by 5, and always pick the easy ones. It doesn't matter which route you take, you always get down to the bottom where you find all of its prime factors, and you can express it as a power just like this. Okay? And the reason why I was saying that this is by far the best method for this type of question, as opposed to what I did in the last part of this video, is if I did just write out all of the factors for a number and then just picked out the prime numbers, what I might be in danger of doing is missing out this. So missing out when I've got two of the same prime factor that make up a number. If I was just listing them out all together, you'd only account for one of each, and you wouldn't account for times when you've got 2 or 3 or however many of the prime factors that make up that number. And that's what makes this factor tree by far the best way of doing this. Okay, so just to summarize then what we've been going over in this video, we started off by looking at some multiples, and we said that these were basically just the times tables of that number. So if you're asked all the multiples of 6, you'll go through the times table of 6. If we're looking for some factors, a factor is just all the numbers that divide into it. And finally, some prime factors are just like normal factors, but only the ones that are prime numbers. That bit's really important, and I showed you guys how you could find all the prime numbers or all the prime factors by going over the factor tree. I hope you found this video useful, guys. If you're interested in some more videos from Mitch Maths, then go check out my YouTube channel. I'll be throwing this on my website soon, and I'll see you in the next video. Thank you very much.